Okay, so the lesson 36, part C, guys. This is what they call boat in the water. Now, the boat, why did they not come up through there? On the screen here it's good, but up there it's not.
Ooh, should have got $3.
Okay, after we got back to the internet here, it's boat in the water problems. Now, boat in the water problems deal with going upstream and downstream. And there's a big difference between going downstream and upstream. If I was going to be traveling downstream in my canoe, would I have an easier time, or would I have an easier time going upstream? Downstream. Why? Because the current of the river is going to help me along. So if the current of the river was 5 miles an hour, and I could paddle at 3 miles an hour, I'd actually be going about 8 miles an hour. Now, if it was the other way around, say I could paddle 5 miles an hour, and the current was 3 miles per hour, and I was going upstream, I'd only make what kind of headway? Yeah, I only have a 2 mile per hour gain in my rowing ability. I wouldn't go as fast. Now, here's a cool thing. This idea works not only with water and boats, it also works with airplanes and the wind. So if you fly your plane with the wind, or even think about riding your bike with the wind, or running with the wind versus running against the wind. The wind is pushing against you. It negates your own speed. It slows you down. Okay? So, there are two main equations for this. One deals with going upstream and downstream, or with the wind or against the wind. And so we say downstream is the boat plus the water times the time down equals your distance down. Now this hopefully makes sense. Wait a minute. We kind of seen this equation before. Something times time equals distance. Rate. So B and W are the rates of yourself and the wind or water. Then we go upstream. So it's B minus W. So if you notice that both going upstream and downstream both have that rate times time equals distance equation in there, but it does vary differently because times going up and times going down are going to be different. Your distances could be different. The things that are going to stay the same or consistent would be your boat or your airplane speed, and your wind or water speeds are going to be the same going up that stream or down that stream. Okay? And so what we're going to do in our first problem is not talk about a boat, but talk about an airplane traveling. And so here it is. It says one day, Selby, I don't know why it's not Shelby, but Selby found that her plane could fly at 5 times the speed of the wind. She flew 396 miles downwind in a half hour more than it took her to fly 132 miles upwind. What was the speed of her plane in the still air? So basically, what would it be the speed of her plane? And what is the speed of the wind? So what I see is there's two parts to this. There's a downwind side and an upwind side. There's a downstream, upstream. So I use those two equations. And so let's write those things down. We had to go and say, well, we said that her plane, we'll say, plus the water is, when she's going down, that'd be TU equals, not U, but TD equals distance down. Do we know any of that information?
Yes.
Yes, we actually know how fast her plane is. How fast is her plane?
5 times the speed.
It's the 5 times. Yeah, it's B does not equal the wind, right? The plane does not equal the wind. It's actually 5 times the wind. So could I place that there?
Yeah.
And so I get 5W plus W time down equals, how far should go? Going down. 396.
132.
Now if I go up, it's B minus W TU equals DU. Yes?
Yeah.
But BU is 5W, so isn't that 5W minus W TU equals 132. So she's gone 132 miles, going up against the wind. I think I could clean both of those up. This would become 6W TD equals 396. Yes? Going over to the other one, I get 4W TU equals 132. Interesting. Now there's a connection between these two. What was that connection? What's like the one piece we haven't actually touched yet? Time. What's the connection between the times? I don't think that if I move over here and I go TD is equal to TU, is that true?
Yeah, it is.
It's, what about 1/2? So it's a half an hour somewhere. It was downwind and a half hour more than it took her to fly upwind, right? So which one gets the plus half? The TU gets the plus. Because the down time is a half hour longer than the up time. So you need to know the TU, the up time, and once you know that, you add a half an hour to it, you get down time. What do you think I'm going to do? What do you think I'm going to do? Yeah, I'm just going to substitute, guys. I am going to substitute this in for that. It's a highlighter. Okay. So, what do we get here? I would get 6W times TU plus 1/2 equals 396. Yes? Okay. What can I do with the 6W? I can distribute, not factor it in. Factoring's pulling apart.
What's the difference?
Factoring's like kind of dividing. Distributing is like multiplying. So 6WTU plus 3W equals 396. Wait a minute. We still have this equation and that equation now.
Could we do the one or the
Elimination. Guys, we could try elimination, but the second equation with the 4WTU doesn't have any W's in it. So that might get a little tricky there. So could I just use simple substitution?
Yeah.
I don't know.
Oh yeah, you should, okay, Actually, no.
Is that not supposed to be?
Oh, TU equals.
That was my bad.
Like that, just writing your pen.
Okay. 396. Sorry. Okay. But I'm going to use substitution. Look, this here has a WTU in it. This has a WTU. Could I actually solve for this top, this one here? Is WTU? Divide both sides by 4. So a WTU is equal to?
I would like to say like 23, I don't know.
Probably like 30,
33.
Do you want me to check?
38.
34?
Do you want me to check?
You should always check. You guys should have your calculators out.
No, we don't.
33.
33. Oh, see, told you to check that.
33.
33. And you know what can I do, guys?
Substitute it back in there.
Put it into there.
6 times 33.
6 times 33
It's gonna be, 130
plus
66.
3W equals
198.
396. 198 plus 3W equals 396. And then
Minus 198 minus 198.
198 is
396 minus 198.
so 3W equals 198. Divide both sides by 3. The speed of the wind is?
66.
190. That's a cold rain. I'll say 5 times.
That is the speed of the wind.
But we need the speed of the.
We also need the speed of the plane, and the plane is?
These two the same.
No, 5 times the speed of the wind. 5 66. Also 5 times 66.
5 times 66. So I go 5 times 66 is B,
5 times
which is
330.
330 miles per hour. So we want that. So we want this and that. We answered it. The plane is going 330 miles an hour, and the wind, not water in this case, is 66 miles per hour. Okay?
Really going.
So your homework, oops, is this problem, which I'm sorry is kind of small. It is in the book. I have it on the board as well.
Is it number 1?
But number 1 is about group.
And I want you guys to do page 259, 1, 5, 28.
Just to this one question.